Hi, welcome to Data Appreciation, which we'll be doing the Google Skills Code Lab, identifying different batch and streaming data sources. So it's a 1 hour 30 minutes lab, and the activity overview says timely access to data is critical for organizations to respond quickly to market changes, customer needs, and operational issues. Batch processing is a method of collecting large volumes of data over a period of time than processing it all at once and then processing all at once. It is best for processing large amounts of data and tasks that do not require real-time processing. Streaming processing is a method of processing data as it is received. It is best for processing data continuously in real time. It is important for data analysts and data scientists to understand the difference between the two, since both processes have their own advantages and disadvantages. As a data analyst, knowing when and how to apply batch processing or streaming processing helps you optimize the performance of data processing tasks, minimize time delay in data processing, and provide more accurate and timely data insights. In this lab, we process and collect data for specific purpose, observe the data loading in BigQuery tables using both computer-assisted batch processing and stream processing methods. Here's the scenario. You have been asked to help Meredith, the lead merchandiser at the local e-commerce, monitor the results of their promotions and price changes. Merchandisers set prices and make sure they sell the inventory they buy. For example, if t-shirts for a sports team are overstocked in a championship year, the retailer might decide to lower the price so the merchandise sells faster. That way, the store does not end up with unsold stock. For this task, Meredith needs to view the number of items added to shopping carts two ways. Near real-time monitoring will allow Meredith to view the number of items added to shopping carts as they are available. Minute-by-minute monitoring will allow Meredith to view the number of items added to each shopping cart in increments of 1 minute. This data will help Meredith track the effectiveness of their promotions and price changes over time. They can then use this information to help improve the shopping experience for their customers and increase sales. Atem, the data architect, points out that shopping cart activity is streamed into one of the tables in BigQuery. You need to help Meredith understand how to find the data she needs to monitor the merchandise. Here's how you do this task. First, you search for your data set and an associated table. Next, you run a query to display the time each product was added to the shopping cart. Then, you will rerun the query. Finally, you would examine the properties of the shopping cart and other tables. So, to set up, we would start our lab. Next, we would open Google Cloud Console in incognito window. So here we can see that we can view the menu with a list of Google Cloud products and services by clicking on the navigation menu to the top left. First of all, agree to the permissions. So here is our navigation menu. Once we click on our navigation menu, see all products. So in the navigation menu, we'll select BigQuery. Note that the welcome to BigQuery in the Cloud Console message may appear. So we'll select BigQuery. So this is the welcome to the BigQuery in the Cloud Console. Next, we'll expand the list of datasets by clicking the drop-down arrow next to the project ID. So next, we would select a project from the Google Cloud title bar, then select the project link from the select the project dialog. I have a project here. It's already selected. What's here? This is our data set. So we'll find data set named the look GCDA and click the drop down next to it. So this is the drop down next to it. Next, we're going to select the table named shopping cart. Select our table named shopping cart. So we have 4 fields under our table shopping cart. We'll click the query button to open the query editor and select in a new tab. Click on query. So we can see a populated untitled tab has opened. We'll replace the populated data by copying and pasting the following query. So this is pre-populated. We'll just take this out and impute our own query. So we are seeing now our query is good to go. Next, we run query. Then the query results will display in the table format below the query editor. So once we run it, we'll have a table here. The results come in a table format. We have the row number, we have quantity field, created at field, product ID, and session ID field. And they said it was a busy shopping month. Where did notice multiple items being added to the shopper's cart. Which column displays the time the product was added to the shopping cart? So which column displays the time? So I think the column that displays the time is the created at, because we have the year and time, hour. So that is the created at column. Next, note that the time of of the most recent entry, which we displayed at the top of table row 1. So we're now told to run the query again. Time of position entry is 3:20, 40 seconds. So let's run the query again. Next one is 3:21, 8 seconds. Now said if the time of the most recent added row is same after you run the query again, you know it is newer because data is continuously added to the table. Data is continuously added to this table, so queries can be run on the latest data as soon as it's available. This changes the output of the query. So we'll now click on the shopping cart table in the Explorer area and then click on Details tab in the query area. So let's go to the shopping cart table and then we go to Details. Examine the shopping cart table properties. The section streaming buffer statistics is an indication the data is being streamed into the table. So the section called streaming buffer statistics, this is it. The earliest entry is February 26, 3:32 PM UTC1. Next, what we have next, what we have next, what we have next is an indication the data is being streamed into the table. Now examine the properties of the orders table. Click on the orders table in the Explorer area. Now examine the properties of the orders table. Click on the orders table in the Explorer area. Go to the orders table. Details. Is the stream buffer associated with the orders table? So let's go to the, so there's no streaming. No, but the table is not connected to the streaming source. Loaded as a batch rows after. Now we're going to copy the into the query editor and run the most recent rows on the orders table. Now click on and examine either the change in the result. So let's see. Our results are order ID 73125 and 63004. So there's no change in this order ID. Time here is 2023, October 18, 1926, 1852. So because the most recent sale change, no. So now we're going to copy the following query into the query editor. Select category, format, timestamp from our data set, and inner join on product ID, where product ID is equal to product category is equal to jeans, group by category, order by added at minute. So this query displays the number of products from the jeans product category that were added to the shopping cart table each minute within the last hour. So let's run it. Have category added and some quantity. This query displays the number. Run the query at least 3 times, waiting about 10 seconds between runs and observe the results. This query is an example of data source for a dashboard because the query is based on shopping cart table, which is concept related through streaming source. The dashboard will get fresh data every time the query runs. So what we have here is 1527 as the most recent. Let's run it again. The new time is 1528. So let's check our progress. Now let's learn more about this query and its main components. Locate the names of the tables used in this query. Query joins the look shopping cart and the look products tables using the product ID column. This ensures that only rows that match the product ID on both tables are included in the results. With the names, what columns are referenced in this query? The created at column from the shopping cart, the quantity column from the shopping cart, the category column from the products table. All of these options. So let's look at the columns that are referenced. So we have product ID, we have the product category, we have the created at. Let's see product category here. So identify the type of join used in this query. Inner join. An inner join is used in this query. A shopping cart row with a value in the product ID that does not exist in the products table will not be included in the results and therefore will not be counted. Because Meredith counted for minutes, asked for minute by minute information, the query formats the created at column as hours and minutes. For example, 10:15 for a quarter past 10 in the morning. Identify the following statement in the select portion. So identify it that format the timestamp, hours, anytime, hour, in time, minutes, created at as will now be brought in as a column called added at minutes. Is this new column. So formatting dates and times is a very common task for the cloud data analyst. You can find more information and examples on how to use the cloud type format in BigQuery's time stamp functions documentation. We'll locate the where statement in this query. The where statement in this query filters shopping cart items by product category and by the time it was created. So we can see it here. Where statement, product category, and the time it was created. Since Meredith is very interested in jeans, the following part of the query removes products not in that category with the first part of the where clause, that is pick product category jeans. The shopping cart is a very active and the shopping cart table is very active and can be quite large. So Meredith also asks to see data for the last hour. To accomplish this, the where clause filters rows using the created at column and uses two built-in functions. One to get the date and time when the query runs, that's the current timestamp, and you want to calculate the time for 1 hour ago, which is timestamp add. The query will only return rows that were created before now minus 1 hour, that's minus 60 minutes or 30 or 59 minutes as the case may be. Now it's determined by the current timestamp function. Minus 1 hour is done by subtracting 1 hour from the current time. Note the time displayed in the query results in the universal time coordinated UTC time zone. It may not align with the time at your location. Storing time UTC is a common practice in global companies. For more information, we'll go back to the same reference, which is time stamp function documentation. We'll locate the following line in the query. It is grouped by product category and added by minute, which is the last line. Grouped by product category, order by added minute descending, ordered last minute descending. Following line groups the results by minute and adds the quantities added for each minute because we use the sum function in our select statement. Since you need to list product category in the results, you must also go by product category. Notice that you are using the alias added at minute column that was defined in the select portion to the query. Locate the order by clause in the query, which is order by added at minute sending. The order by clause populates results in the most recent available by the minute at the top. So good work. We're able to locate the information really needed to stay on top of customer buying trends, and this will help them make timely business decisions about pricing and stock. We did this by first determining if the table was using batch or streaming processing, then exploring and running a query to populate a table in which data about the number of jeans that were added to shopping carts in the last hour by minute. We also learned about the importance of timely data access and the difference between batch processing and stream processing. By observing data loading in the BigQuery tables using both methods, we developed the skills to choose the appropriate approach for data processing. So we have satisfied our tasks here and tell us our task is complete 100%. Then we can now end the lab. Then we click on submit. Our survey. So see you in my next video. Thank you.